So welcome everyone. We're so glad that you can join us tonight for a program on the water quality of Sackett's and East Putney Brooks in Putney. We were going to be, now I'm all tongue-tied. So my name is Margot Gia. I am Natural Resources and Energy Planner at Windham Regional Commission. And we have a couple other water quality partners that we regularly work with online tonight. We have Marie Caduto, who is from Vermont Department of Environmental Conservation. She is the watershed planner for our southeastern region. Hi, Marie.
Hi.
And we also have our guest speaker this evening, and many of you may know him. His name is Ryan O'Donnell. He works for Connecticut River Conservancy, but he has also worked in the past with the watershed group, Southeastern Vermont Watershed Alliance. They were Alliance also. He also works with the Deerfield River Watershed Alliance. And he coordinates water quality monitoring sort of from the whole southeastern part of Vermont and into Massachusetts. And so we're excited to have Ryan here tonight, and he's going to be talking about the water quality samples that have been taken in those two brooks that run through Putney. And then we'll have a chance to have a discussion afterwards, because we do want to hear from you about observations or things you've noticed about conditions of the rivers in that region. So as Ryan is giving his presentation, I'm going to ask that everyone keep themselves on mute. That way we can reduce any background noise that there might be. As he's speaking, if you have a clarification question, like about a slide that he's showing, please feel free to just unmute yourself and jump in with a question. We won't necessarily be able to see you if you're just kind of raising your hand, but feel free to jump in. If you have a more substantial question that's more of a discussion item or observation, we're just going to ask that you hold those to the end so that we can all have a comprehensive discussion and Ryan's able to first finish his presentation. So at this point, I'm going to pass it over to Ryan.
Great, thank you, Margot. So as she just said, I coordinate a monitoring program throughout southeastern Vermont and into Massachusetts and actually all the way down into Connecticut. And one day soon, hopefully more in New Hampshire. But one thing we've started doing, CRC and Windham Regional, through support of these tactical basin planning grants, working with Marie, is doing these local outreach events, and I've found them really helpful, and I hope that you will find it helpful as well. So I'm going to show my presentation. Margot, did you hit record? Oh yeah, you did. Great. So I will be discussing the water quality of the Sacketts and East Putney Brooks that flow through Putney, and we're looking at the data from 2017 through 2022, and I believe we only monitored Sackett's Brook starting in 2016, I think, so we're only missing 1 year, but these 6-year kind of chunk feels to me like a recent relevant look at the brook. So I want to start off by reviewing what a watershed is. I think about them all day, every day, but I realize not everybody's doing that. So a watershed is an area of land that drains to a particular body of water. If it rains, if it snows and then melts, or if you just dump a bucket of water outside on the ground, where's that water going to end up? And the area, kind of like your sink, if you get the water in the sink, it goes down the drain. If you get it on your counter, it might end up on the floor. So the sink is the watershed of your drain. And so, here we have a great diagram full of little cartoons, but you can see this dotted yellow line is the outline of the watershed. And then within this bigger watershed, we have a small tributary that has a sub watershed. So, the brooks we're talking about today go directly into the Connecticut River. So they're part of both the Connecticut River watershed and their own little watersheds as well. And another thing I like about this diagram is it shows, different land uses. So we have, a farm, and we have a city and some roads. And that's important because all of the things that we do on the land affect the quality of the water itself. So like I just said, land use, what you're doing on the land is a really big impact on what the quality of the water is. And one of the big reasons is because of runoff. So runoff is water that, rain or snow melt that, hits the ground, and it doesn't get picked up by trees. It doesn't enter the ground. It just goes straight into the nearest body of water. And so on the left, I have this chart that shows you how different land uses, how the water from rain or snow melt acts. And so in a fully forested land use, you have about half is in the blue bar, and that is evapotranspiration. So that's both the water that is taken up by plants through the process called transpiration, and also the water that just evaporates directly into the atmosphere. It's actually really difficult to measure how much is evaporating versus how much is transpirating through plants. So those get lumped together. And then the brown and the yellow are both types of groundwater. And so about half of the rain or snow melt in a forest ends up in the ground. If you change land uses to pasture, which is, mostly grass, but still green and not too impacted, we're getting a little bit more groundwater, a little bit less evapotranspiration, and we're starting to see this red line, which is surface runoff. Like I mentioned, water it's not being filtered in any way, either through the plants or through the ground. And so it's picking up whatever it has with it. It encounters on the ground, dissolves it, and brings it into the nearest water body. If we're looking at a suburban land type, and I know doing these presentations in Vermont, saying suburban and city, that doesn't really apply to, but you can still think about these principles. Suburban being somewhere where there's a lot of sidewalks, there's a lot more roads, there's more lawns than there are, trees or pasture. And here we're seeing, a little bit less groundwater than the pasture, like a lot less evapotranspiration, and we're seeing a lot more runoff. Just because there's more impervious surfaces. So impervious meaning that the water can't get through to get into the ground. And so it's just going to flow along the road until either it ends up somewhere where it can infiltrate the ground, or it will go into the nearest body of water. And then if we were looking at a city, which is just an area, in this case, is just an area of land that's mostly paved. There's not really any green space. You're gonna lose some water to evaporation and maybe a couple street trees, but most of that is runoff. And so what we see is that water quality tends to be worse, basically the more pavement and the more runoff that we get, because the trees in the ground do a lot to filter our water. On the right, I have a chart that you don't need to worry really too much about all the words, but I really like it. And it's talking about how a stream reacts based on urbanization. So how basically, if you pave over a watershed, how does the stream react? And so this black line that's filled in with light blue at the beginning is a period of rainfall. So you can just imagine this is one rainstorm. And the pink line is how the stream responded originally. So it would slowly rise up, it would peak, and then it would slowly come back down the river level. But the more pavement you introduce into a system, you get something that looks more like this blue line, where you have a much faster rise, a higher peak, and a much faster fall down. And so we call that flashiness. That's something that we see a lot, like along Route 9 and the Whetstone Brook going through Brattleboro. Brattleboro floods a lot because Whetstone Brook is really flashy, and part of why it's flashy is because it has, a road along it the whole way that's just dumping a little bit extra water into it. So looking at the watersheds in Putney, I put these on a Google Map space because chances are, if you're looking at a map, it's probably a Google map or an Apple map or something like that. So I wanted to show you something that you're familiar with. The more southern one is the Sackett Brook, and you can see it goes through here. We have the yellow outlines of the towns, and then East Putney Brook has this kind of very long, skinny watershed north of Sackett Brook, and they drain into the Connecticut River. Here's a look at our water quality monitoring sites with also a satellite view, so you can see how many trees there are, how many farms, the roads, things like that. Get a better sense of the land use. So the Sackett Brook, I have these purple diamonds. Apologize if they're a little hard to see, but we've tested just upstream of I-91, just upstream of the wastewater treatment facility, at the end of Mill Street, a little bit upstream at the conservation site, just above the dam, a little bit further upstream from that, off of Kimball Hill Road, and then at the Portal Swim hole. And then on East Putney Brook, my controls are, we were monitoring the River Road culvert, and then we actually monitored up off of Millbrook Road for a couple of years. And you may be thinking, why have we monitored the Sackett Brook in so many more places than East Putney Brook? And I think you'll see why. So first I want to look at the stream flow. One of the hardest things about looking at our water quality data is it's really affected by the stream flow. And so this is the stream flow from 2017 to 2022 on the Saxtons River, which is, just a little bit further north than Putney. And we classify our flows when our volunteers take a sample, they also are noting the level of the flow as either low, moderate, or high. And low flows are just the bottom 25% of flows ever observed. And high is the top 25%. And then moderate's like the middle 50. And so they're a little hard to see, but this lower dotted line is the low flow threshold on the Saxtons River, and the higher dotted line is the high flow threshold. This is with a logarithmic scale, just so you can see the variation. And in particular, in the past 6 years, we've had both some really, really high flows, these peaks up over 1,000 cubic feet per second are pretty high, but we've also had some really low lows. This, pink line is last summer. This blue line is 2020. So we've had a large variety of flows that we've observed, and those affect the individual results. So the first thing I'm going to talk about is E. coli bacteria. So this is used to determine the level of risk for recreation, such as swimming or boating. Not many people, I think, are boating too much, although you can paddle up, from the Connecticut River, up the mouths of these places. But so the EPA in the state sets the threshold, the level of acceptable numbers of E. coli for primary contact, which is something where you're coming into full contact with the water, like swimming, and you're likely to get the water in your mouth, per se, at 235 organisms per 100 milliliters. And secondary contact, which is boating, where it's something where you're not in the water, but you're maybe likely to be splashed with water, like boating and other things, is the levels at 625. But I mostly use that 235 number for these smaller, wadable streams. You're either going to be swimming or splashing around in them. E. coli is an indicator organism, which means that it's used to indicate whether or not a water has been contaminated with human or animal waste. And so E. coli is a bacteria that's found in the guts of all warm-blooded animals, humans, animals, birds. And so its presence indicates that there's likely some poop in the water. And with the contamination of waste, there's also the likelihood of other things that could make you sick, but are much harder or more expensive to test for. So other waterborne illnesses. So we use E. coli bacteria. It's relatively abundant. It's easy to test for, relatively inexpensive, and it's the standard indicator organism. Its sources include agricultural and urban runoff, failing septic systems, leaking sewer pipes. Pet waste is a big problem in some areas, or wildlife. Sometimes if like a bunch of pigeons live under a bridge, that can be a source, etc. And we see increased levels after rainfall because, it rains, and if there's a lot of runoff, any poop the water encounters will go with it into the water and increase those bacteria levels. So here's a look. I'm going to present all the data in a couple different ways, because I feel like since we can't have like a three-dimensional like hologram to show you all, there's a bunch of different dimensions to this data. So the first is a longitudinal look. So on the left, we have the East Putney Brook, and on the right, we have the Sackett's Brook. And then across the bottom, we have the river mile. So how long, kind of where in space the site is. And on the top, we have dry weather samples and wet weather samples, because like I said, E. coli and some of the other parameters are really affected by whether or not it rained recently. So the East Putney Brook, which we have, 2 sites for, but mostly we have only tested the upstream site a couple of years, but you can see these other dots of other colors. In dry weather, it's great. It's really low, and it's really low compared to other rivers in the region as well. So the East Putney Brook doing a great job. And then this past year, we had in 2018, we had a couple really wet days, and we got some high E. coli levels. But all the other years, it was pretty good as well. So the East Putney Brook tends to do really well, but in really heavy rains, we could still see elevated bacteria, which is just true of most of the rivers in our region. The Sackett's Brook is not quite as doing a good job. So even in dry weather, you can see all these lines. So upstream at the Portal swimming area, we have the swimming hole. We have tends to be below that threshold. That's that dotted red line, tends to be really good. And then as we move down into downtown Putney, and then through the center of town, it peaks kind of in the center of Putney, and it's well above that threshold. And all these lines are above the threshold in wet weather. So Yeah, lots of bacteria in the Sackett Brook, especially around the town. Sorry, my thing is covering my notes. Just that the highest numbers right here tend to be just upstream of the dam. And the dam could actually have the water coming over the dam and being aerated could actually reduce bacteria downstream a little bit. So it's likely that the sources are upstream of the dam. This is another look at the same results. So instead of doing it by year and mile, this is by year or by flow level, like we talked about, and site. So you can see on East Putney Brook, we have a couple of outliers above the threshold for swimming, but overall, most of the results tend to fall below it, and the average for all the results across these all 6 years is well below the threshold. So that's really good. Once again, looking at the Sackett Brook, some of these bars are just fully above the line. And you can actually see that in really high flows, and we haven't gotten a ton of bacteria in really high flows, but you can see that it's almost not as high as as low and moderate. Bacteria, it's a little harder to see trends with low, moderate, high flows just because it really depends on whether or not it rained, but I wanted to show all the data in the same way. And then people always ask me if there's trends, especially in the Sackett Brook. We've been trying to chase down sources of bacteria since we started monitoring in 2016. And it seems like it's kind of getting better. And so, I just plugged these into my program and it told me whether or not there was a trend at each site. And it seems like maybe there could be, but the error bars, that's that gray thing, is pretty big, so it's hard to tell. But these are more clearly going down a little. But this green line, which is upstream of the dam, is pretty flat, and that seems to be where consistently high levels tend to be. Next, I'm going to talk about nitrogen. So nitrogen is a nutrient that affects plant growth. If you're a gardener, you're probably thinking, oh, I always want more nitrogen for my plants to grow big and healthy. But you can also think about how that affects plants and algae that live in the water. So nitrogen is the controlling nutrient in saltwater ecosystems. And that's important because our Putney water drains into the Connecticut River, and then the Connecticut River goes down to Long Island Sound, which is saltwater, and they do have too much nitrogen. And the excess of nitrogen is causing algae blooms and plant and fish die-offs, and all of that creates a lack of oxygen in the water. So that's bad. And so we want to reduce our nitrogen contributions to the water, to Long Island Sound. We measure total nitrogen, which means that it counts all forms of nitrogen, including nitrates, nitrites, and ammonia. If you don't know what that means, that it doesn't matter, just that there's different types of nitrogen and we're trying to measure all of them. Its sources include agricultural runoff, wastewater, failing septic, and nitrogen is very mobile, and so its numbers tend to be less affected by rain, but not always. So here we have the same graph of the river miles and the years. On the left, on East Putney, unfortunately, because of changes to the program, we haven't been monitoring nitrogen at both sites, or many of the other programs at both sites at the same time, so it's just dots. But the threshold I'm using here is just an EPA recommendation. All of these results meet the Vermont state standard. CRC thinks that we should be holding ourselves to a little bit of a higher standard. And so I'm using this EPA recommendation for what natural nitrogen levels would look like in our region. So East Putney Brook below that threshold. Usually, like I mentioned, wet weather graphs for total nitrogen are similar, if not lower than dry weather, because either it's about the same or there's so much water it dilutes the nitrogen. But this graph shows that some years wet weather is moving a lot of nitrogen through the system. And so I think that's really interesting and might indicate some relationship to where the nitrogen is coming from, if it's coming from runoff in particular. And the dam is about here, if you're wondering. This is by flow. And you can see, I'm seeing this more in headwater streams as I'm doing these analyses more, and we're monitoring more headwater streams and doing better high flow monitoring. But where we have low flow is the highest, and then moderate flows are the lowest because, like I said, diluted. And then the high flows, which are in blue here, are kind of in the middle, which is an interesting pattern. But it's just that when we have really high rain and really high flows, and there's a lot of plant matter and things moving through the system, that we're picking up some more nitrogen. Either way, East Putney Brook is looking great. And you can see that the highest consistent levels that the nitrogen levels tend to be higher above the dam than below the dam, because this dam's between the above dam site and the conservation site. And so the dam might be actually trapping some nitrogen and storing it for later, which is a thing that dams do that we know about. Once again, looking for trends, it's pretty messy. So I'm going to say no trends. If you're wondering why I show you a bunch of messy trend slides, it's because it's a question I always get asked and it's the hardest to answer. So I just wanted to show you that it's a mess, which is to say that things are probably the same and just affected by weather. I'm going to talk about total phosphorus now, which is also a nutrient affecting plant growth. In this case, though, it's the controlling nutrient in freshwater ecosystem. That's why in Vermont that we hear a lot about it in relationship to Lake Champlain and other lakes. And we do care about it because we do have, slow moving freshwater impoundments on the main stem of the Connecticut and on some of our tributaries that we're starting to see the effects of too much phosphorus in as well. So once again, total means it counts all forms. So that's organic, inorganic, dissolved, and suspended. Like nitrogen, its sources are agricultural runoff, wastewater, and failing septic systems. And the interesting thing about phosphorus is that it's very sticky. The volunteers know this because they have to collect phosphorus samples in glass tubes and everything else is plastic. And it's because the phosphorus doesn't stick to the glass quite as much. And so that means that it sticks also to sediment. And so we see that its levels are highly correlated with rain and turbidity, how cloudy the water is. Once again, on East Putney Brook, we weren't monitoring the same things at the same time, the same things in the same places at the same time, so we don't have any lines. But here you can see that East Putney Brook is pretty good, but in wet weather, the headwaters are maybe above the Vermont standard, and that's actually pretty common. In southeastern Vermont, we have a lot of that great fertile glacial soil, and it likes to get in our rivers when it's raining. So we see those higher phosphorus numbers, even on undeveloped streams in wet weather. Looking at Sackett's brooks, maybe we wouldn't be surprised to see that the phosphorus levels are once again much higher. Similar to the E. coli, the Portal Bridge site, the most upstream that we test, meets the standards, the Vermont state standard, and then immediately goes up. And you can see in 2017, we had some really high levels, and I'll discuss that in a second. And that was in dry weather, but in wet weather, we're seeing slightly higher levels, and you can see those higher levels at the headwater. I wouldn't even call the Portal Bridge the headwater site. It's kind of just like the above most development and agriculture. So here we can see, I'm going to show this again with readjusted, rescaled, but you can see the single outlier site that was collected, and it's a real result. That was a real amount of phosphorus in the water, and what was happening was they were dredging the dam. So they were basically letting all that sediment go, and we captured that. And I left that into our data set because I think it's really important to see, that in systems like this, where we have a dam that's holding back a lot of sediment and a lot of nutrients in that sediment, that when we dredge them, a lot of that ends up downstream, it ends up in the Connecticut River, it ends up behind other dams, and it ends up in Long Island Sound. Just some food for thought about dams and how they affect our rivers. So this is the same graph, but rescaled so that you can see it without that really high result. And you can see we have these really high flow phosphorus level. And you can see the dam is here. And so we have the highest levels just above the dam. And once again, that the dam is probably holding back some phosphorus from moving downstream most of the time until something causes that sediment to get suspended in the water and head downstream. But either way, these numbers are still higher than our standard. These are mostly flat, so once again, no trends. We're not seeing any major changes. Chloride, we've only been monitoring for a couple years and not at very many sites here, but I wanted to show you because I know we've done some of it. So chloride is naturally found in both salt and fresh water. Chloride ions separate from chloride salts, such as sodium chloride, which is table salt. Other salts, I don't need to say them all. It can also come from water softener, wastewater effluent, or fertilizers. But concentrations tend to be higher in areas with lots of pavement and other treated surfaces. High chloride concentrations in freshwater can stress or kill aquatic plants and animals. There's no specific standard for chloride in Vermont, but they say to go with what the US EPA recommends, and they recommend less than 860 milligrams per liter for acute toxicity. So a single dose or a fish would not be able to survive at all in levels of that, or 230 milligrams for chronic. So prolonged periods of that above that would be fatal to creatures. This is a very boring graph because it's just dots. But as you can see, we're at like between 4 and 8. So we're well below those toxicity numbers. So that's good. And so you can see this is something that really dilutes as flows go up, which is sometimes what our nitrogen graphs look like, but not over here in these rivers. But yeah, this is what a strong dilution looks like. I should note for chloride and then specific conductance, which I'm going to talk about next, that we only sampled during the summer. And so we're not capturing like immediate runoff of winter road salt. Specific conductance is a general monitoring parameter. It's something that we do in-house at CRC. So we don't have to get grant funding for it. It measures how many ions are dissolved in the water. So it's just kind of like how much stuff is in the water. So it could be road salt, it could be metals, it could be dirt, some of it could be phosphorus and nitrogen ions. So the sources that affect it the most are road salt runoff, geology, what the local rocks are, and it tends to become diluted with rain. But we monitor it, one, because it's really easy, and two, because it may catch areas impaired by other parameters that we don't monitor. So if we see a sudden spike somewhere or a sudden change, we can go back and look at it and say, what should we be looking for? And maybe test the water for something else. So I will probably call it both specific conductance and conductivity, but they're slightly different. So we are actually measuring specific conductance, which is a measurement that's adjusted for temperature. So, you know, electricity, you know, goes through water differently based on what temperature it is. And so this is set to a standard temperature. And then conductivity would actually be temperature specific, but it's a little easier to say. So I slip sometimes. And there's no standard for this. So you can see East Putney Brook is actually like a pretty straight line in this kind of upper up above 150 but below 200, which is on the higher end for our region, but since it's a straight line, that's probably more of a natural occurrence. And you can see a little bit of dilution going on the blue line, but overall it's fairly similar and a little bit diluted. Sackett's Brook, you can see these numbers are a little higher. Sackett's Brook is on the higher end for the region, but this isn't like a shockingly high number. And you can see a little bit of dilution happening in wet weather. Here we see that strong dilution effect that we saw with chloride. So, and similar in Sackett's Brook, not a whole lot to say there. It's pretty consistent actually upstream to downstream. So there's nothing lurking is what I see. And this is something that the one where I am seeing trends, the graph is this, the conductance trend graph. And I actually really want to look at all of our data that we have to see if this is a long-term trend of increasing conductance, and that's often attributed to road salt. And ignore my Vermont standard, it's left over from a different parameter. I apologize. The last one is turbidity, or how cloudy the water is. So that could be clay, silt, inorganic, or anything that can make your water look dirty like this is contributing to turbidity numbers. You measure it by scattering light. And the Vermont standard is 10 for Class A and cold water, and 25 for warm water, Class B. And I feel like I couldn't quite figure out cold water Class B numbers, but somewhere between 10 and 25. And I think we're cold water Class B looking at. But East Putney, spoiler alert, is I think East Putney Brook's ready for
Well, we're glad you could rejoin us. So I think we missed what you were last saying there on
Yeah, I was saying, spoiler alert, I think that East Putney Brook is ready for Class A. And I have my presentation on here. I just have to open it. I'm very thankful for the cloud because I just switched computers. Turbidity, yes. Present. Great. All right, so here we are again. The turbidity is actually doing pretty well in East Putney Brook, which you said, and Sackett's Brook is actually pretty good as well, except for we have that really high number in 2017, which is that dam dredging day. And then in wet weather, it's a little higher, but it's not bad. And you see there's a large data gap between 2018 and 2022. The state stopped including it in its testing program in 2018 because it's a little finicky. But we were able to buy a turbidity meter and pick up that monitoring again. So this is by the flow level, and once again we have these like really high outliers, and you can see this is immediately downstream of the dam and then a little bit further. So you can think of that sediment is settling down into the stream bed as it moves, and also that there's more water that maybe is less turbid coming in, but I think I guess. So this is looking at the numbers without those outliers. And as you can see, it's all mostly below our standard, so we really like to see that. So I'm going to say one more thing about that, which is that even though it's higher kind of from Kimball Hill Road downstream, we would naturally expect higher turbidity and kind of the flatter, slower moving part of a river. So the fact that it's more turbid downstream is not necessarily a reflection on poor water quality, at least caused by turbidity. Looking at our trends again, things are kind of flat, so not really not getting more or less turbid. Oh no, my conclusions have disappeared. Well, oh, there they are. East Putney Brook is a high quality resource. That's my biggest takeaway from monitoring. We monitored that upstream site for 2 years as part of the state program in order to help recommend to Marie that we think it should be upgraded and be protected as a high quality resource. And we actually won't be monitoring that upstream site anymore because we have a pretty good sense that it's really high quality. And so, we might go back and check every once in a while, but it won't be part of the regular monitoring program. We will continue to monitor the River Road culvert because we know that's a very popular swimming area, and we want to keep monitoring the bacteria. So Sackett's Brook, on the other hand, struggles with really high E. coli, bacteria, and phosphorus. The combination of that points to agricultural or wastewater sources. I can't say more about like what those might be, but that combo says probably something that's got both bacteria and phosphorus in it. The dam under Main Street traps phosphorus-laden sediment and nitrogen-laden sediment, which provides habitat for bacteria to colonize. So it's possible that part of the bacteria problem is that the bacteria lives in that great rich sediment, and then it gets mobilized during the storm. We're just starting to learn more about bacteria, E. coli colonizing stream sediments. And so I'm not sure if that means it's more or less risky to swim in the water. We're still learning a little bit about that. But the dam because it's trapping all that sediment, may help attenuate water quality problems downstream, except for when it's dredging or except for during really high water when you're churning up all that sediment and spilling it over the dam. So I'm going to answer all your questions, but I also want to know what your quality or what your water quality concerns are. And as we work particularly in the Sackett Brook, what are some potential sources of nutrients or bacteria that we should know about? And of course, I'm happy to answer any other questions. So I'm going to stop sharing for now, but I can bring back slides as we need.
I have a question.
Yeah.
Do you think that the elevated E. coli above the dam could be due to the beaver activity there?
It certainly could be. Beavers are a known source of, well, anything that poops and is warm-blooded is a known source, but sometimes bacteria can be attributed to beavers.
Can I speak for the beavers?
Yeah.
We also have beavers in Wilson Pond. And at one point when they were dredging, I don't know what year it was, I took water instead of, I couldn't go to the usual above the dam site. So I took water from the stream that was coming from the Wilson Pond to behind the dam. And that E. coli count was less than the usual E. coli count behind the Kimball Hill houses.
Yes.
So
yeah, I have that data point.
Something in addition to beavers.
Yes, it's probably not only beavers.
And then the other thing that I finally revealed, having sat on it for years, was that some of the houses on Westminster Road, up Kimball Hill Road, along that, well, the sewer line goes all the way out to the Putney Central School. And the sewer line in town, people had to connect to, but the extension out to Putney Central School, it wasn't required. And some of the houses up that way are still using their own septic systems. They're not on the sewer system.
That's interesting, Anne, and good to know.
Yeah, the thing about these places that have high bacteria, it's not just one thing. So it's not just the septic systems, it's not just the beavers. It's always a complicated picture, which is part of what makes this very challenging. But Anne has been has been one of my super volunteers for sure, and has helped be local eyes and ears to help figure things out. Particularly, I think she and Tom Ledger helped me figure out the extent of the bacteria problem when we first discovered it, so that we could jump into kind of where to select sites along the stream. And so we determined that the Portal Bridge swimming hole was the upper extent of the bacteria problem. And
Yeah.
it was coming from somewhere downstream of there. And we've been searching ever since.
Yeah, it's made the people who live along Kimball Hill, have kids, and their kids used to just jump in the stream, the mill pond, as it were. And as soon as the testing results started coming out, that ended. So it's sort of sad for the kids.
Marie, can you explain what Class A means for East Putney Brook, or would mean?
Sure. So we have 4 different classes of water in Vermont. One of them is called A2, and that's water supply. So I won't go into that. That won't apply to this. But otherwise, we have A1, B1, and B2. And right now, it's pretty much all B2, except for a few that have purposefully been reclassified to A1. And recently, not too long ago, we established B1. So there's criteria and basically water quality numbers that Ryan has been talking about tonight, that tell you it's a B2 or a B1 or an A1. An A1 is the top water quality, the most clean, the most pristine waters that we have in the state. And it's a pretty difficult criteria to meet. So if East Putney Brook is meeting those criteria now, that's great. And if we take a water, because from a B2 to a B1 or an A1, it provides more protection for the brook. So if someone were to come in and want to build some sort of industry, or a housing development went in and they needed to put in an extra large septic system or something like that, that permit would be scrutinized very, very carefully to make sure that whatever discharge were to be permitted would be protective of the water quality, so it wouldn't be degraded as time goes on. So we want to make sure that the good waters that we have stay in that excellent condition and don't degrade, because one permit comes in and another permit comes in and another permit comes in. And there's those cumulative effects can degrade the water over time. So we want to make sure that doesn't happen. And that's why when we reclassify up to a B1 or an A1, we're adding that next level of scrutiny and protection to the water. So that's where that's coming from. And that's excellent that it's already meeting that criteria.
And if there's, groups in town or individuals in town that are interested in exploring that reclassification, that is something that I can assist with at Wyndham Regional.
It's really interesting how you can have like super awesome water right next door to some really some watershed that's in a little bit of trouble.
Yeah, it is. And you trace the brooks upstream from the Connecticut up, and you look at both of them, and it's interesting that they're so different, because when you look at the land cover and the land uses, there's a lot of forests, but both watersheds have quite a bit of agriculture. And yet, they're so different, because that can be certainly one of the driving factors in nutrients and bacteria, is the level of agricultural land use in the watershed. But in this case, both have it. I think it is more difficult to track down why that they're so different.
Can I be heard?
Yes.
I'm unmuted. Okay. I was just wondering about riparian buffers along the stream to protect it. What size would they have to be? And is that part of the mix? In terms of the East Putney Brook, which is really great news. I knew it was being considered B1 for good fishing waters.
Yeah.
I didn't realize it was up for A classification. Wow.
Do you want to take that, Ryan, or you want me to?
I don't know the exact numbers, but I mean, I can talk about, they part of what we do with our volunteer monitoring program, as they've changed, is that they've wanted us to start looking at these potentially high quality waters. And so I think, they knew that it was a B1 fishery. And then, I've just been really impressed with how high quality the water is. So I know it's been frustrating as we've lost a lot of our sites over the past couple of years for our volunteers, but at least we're able to also start doing this work to identify the high quality waters in our region as well.
That's great. And I think, Anne, your point about buffers is pertinent here, because there's a lot more vegetation along East Putney Brook than along Sackett's Brook. There's much better buffers. And if you're going to look at buffers on Sackett's, pretty much at this point, 50 feet on each side of the brook is what we're looking for, because that's protective of a number of different things. It holds the bank together, the roots, hold the bank together so the sediment doesn't get into the brook. It shades the brook, which where there's no buffers, the water just gets too warm for fish a lot of the time. So while that shade canopy really makes a difference to water temperature, and that 50 feet, as the runoff filters through that 50 feet of buffer, it's infiltrating and it's slowing down, so it has more time to infiltrate into the ground, and those plants are taking up the nutrients, they're using them. So far fewer end up reaching the brook. So that, and 50 feet is pretty much what any of the funding that the state provides for putting in buffers and stuff requires 50 feet. So it's enough to also provide some wildlife habitat and those wildlife corridors up the stream bed.
Okay, thanks.
So Lynn had a question in the chat, and the question is, what is the foamy stuff I see elsewhere in brooks and streams?
So most of the foam
Oh,
is actually natural. Leaves and such, when they fall into the brook and decay, release a surfactant, which is something that makes things foamy. That's what we find in our soaps. And so you see an increase of it kind of in the fall, and then again a little bit in the spring, and it's just these natural surfactants foaming up on the water. However, if it also smells like detergent, then maybe there is a problem.
Are there any other questions for Ryan or Marie? We're lucky to have Marie here this evening. I did notice that Lynn was willing to be trained as a volunteer if you need someone along the East Putney Brook moving forward. So Ryan, I'm gonna just put
You
that.
can definitely reach out to me, but also on this call, Anne and Mary are both volunteers, so they can tell you more about it too.
I just had a quick question, if I can jump in.
Sure.
I know we're at the end. Did you folks do much testing after Hurricane Irene and we had such kind of devastation down here in southern Vermont? Or is it's just kind of ridiculous to even do that?
I mean, there was testing as far as this program goes, like in the Putney area, the volunteer testing. We didn't start testing until 2016, I believe. And also it was kind of like someone was wondering, and we test the Connecticut River and in Putney, and it's actually the cleanest, lowest bacteria site that we test is the Connecticut River in Putney, just downstream of Sackett's Brook. So we're like, oh, let's go test Sackett's Brook and see how clean it is. And we got these astonishingly high bacteria levels. And so that kind of started then Southeastern Vermont Watershed Alliance and now CRC's efforts to track down these bacteria levels. So
But is that common with tributaries to the Connecticut, that you would go up a tributary and find higher levels than in the
Oh,
Connecticut?
absolutely. The Connecticut in general, upstream of like Holyoke, Massachusetts, where we start to have these combined sewer overflows and a lot of degradation to the main stem itself. There's just so much water in it that the amount of water in Sackett's Brook compared to the amount of water already in the Connecticut River and Putney is like very small. And so even though the bacteria is really high, it's getting diluted the second it hits the river. So
Okay. Okay, thank you. I guess we're anticipating over time more potential heavy rain events. And I didn't know if that was good or bad from the standpoint of bacteria counts.
I mean, if you if you look at like the number of bacteria that we measure in the river, the more rain that we've had, the more bacteria we see at every site. So yes, heavy rain events, increased big rain events, increased the number of bacteria after a rainstorm.
Gotcha. Thank you.
And this is something that Ryan is really great about sharing with all the monitors every year to try to get the word out that, you know, in general here in Vermont, it's a great idea after any rainstorm to wait 24 to 48 hours before you go swimming or wading in our streams. Because it's, you know, that higher water levels, it does flush things off the land and into the waterways. So we do see spikes in E. coli after rain events.
And I know it's counterintuitive because when I started, I was like, wait, what, really? I assumed it would be cleaner when we had all that brand new rain in the water, and it's, everything's more diluted. And so I try to work against that misconception as much as I can.
Well, oh, Sarah, do you want to jump
Yeah,
in?
I do. I just want to mention that on Tuesday, May 2nd, the Westminster Conservation Commission is co-sponsoring a program on riparian buffers at the Rockingham Public Library from 7 to 8:15. And Corey Ross, who's the district manager for the Windham County Natural Resources Conservation District, is going to make that presentation. So for folks who are interested in that topic, this should be very informative, and I encourage you all to come.
Thanks for sharing that, Sarah. So it is getting to be that time. So I did put in the chat Ryan's contact email. So if you do have any follow-up questions for Ryan, you can reach him at that email address. You can also reach me at Windham Regional if you have further questions also. So thank you all for coming. This has been a wonderful presentation, Ryan, and it is really fascinating to hear about these two different brooks that are so close to one another but have such different results. And it's nice to be able to hear, you know, have everyone be able to hear this so that we can think about what's best for these brooks moving forward. So thank you again, Ryan, and thank you all for coming.
Thank
Thanks,
you.
everyone.
Thank you. Great
Bye,
work.
Marie. Bye, Marie.